In this section, we're going to look at how we find values of a normally distributed random variable. So essentially what we're doing in this section is we're working the problems that we've done in the past in reverse. So we're still looking at the same four types of problems. So either area to the left, area to the right, area in between, or area in the tails. But the difference is now we're going to be given a particular amount of area, and we have to identify the z-score or the raw score x that marks the cutoff point for that area under the normal curve. So in other words, we're starting with area now, and we've got to work backwards to find the value. So let's say we want to find the z-score that corresponds to a cumulative area of 0.3632. So our first step is going to be the exact same as it was in finding the areas. We want to sketch the area that we're given. So if I draw out my standard normal curve z, and so I know I'm given a cumulative area of 0.3632, so that means area to the left of some value z that we don't know yet is 0.3632. So because this is less than 0.5, we know it has to be on the left-hand side of our mean. So if my mean is here of 0, then we know that there's half of the area there, so 36-ish% is going to be somewhere to the left of there. So somewhere, let's just say here. And we don't know what this value of z is yet. We will find out. And since it's cumulative area, we know that's area to the left. And then let's just label it so that we know what we have. So 0.3632. So now, think back to what we've done before. So to get this area, we would just look up the z-score on the table. And then our area is going to be the value where that row and column intersect on the table. So to work backwards now, we're going to start out by looking in the body of the table. So we're going to look inside our table now for the 0.3632. And so we know it's going to be a negative z-score because it's to the left of our mean. So we're just looking in here somewhere in the middle of the table now for 0.3632, and it's right here. And so now we're going to work backwards and go up and over to get the z-score. So in this case, it's negative 0.3, and then going up to the top 5. So negative 0.35 is the z-score that corresponds to it. And so that's our answer in this case. Now let's find the area for a z-score that has 10.75% of the distribution's area to its right. So same idea, we want to sketch this distribution out. So we know we have our z distribution, our middle is 0. So we have 10.75% of the area to the right of some value z. So we know that's 0.1075. So now we have to think back, how would we get area to the left? So remember, our table always has areas to the left of some value. So what we have to do then is the same thing we did before if we were given area to the right. So if we want area to the left, which is what we can look up on our table, we just do 1 minus the area we're given to the right. So 1 minus 0.1075 in this case, which gives us 0.8925. And this is going to be the value that we can then look up on the table. So we know we have 89.25% of our area to the left of this z-score. Because it's larger than 0.5, we know z is going to equal some positive value. So now we just look up, do the same thing we just did on the last one. We look up 0.8925 on our table. And if we're lucky, it's going to be on the table. So we're looking, we know it's a positive value, so 0.8925. And there it is. So we follow across to the row header and to the column header. And there's our z-score. So in this case, z is equal to 1.24. Now let's look at another one. So let's find the z-score that has a 7% of the distribution's area to its left. So same first step, sketch out your z-distribution. Mean is 0. And we know we have 7% of our data values to the left of this z-score. So we do the same procedure as before. We look in our table for 7%. Well, the problem is when we're looking on here, well, we've got a 0.0694, we've got a 0.0708. Those two numbers are close to 0.07, but there is no 0.7 on here. So what we do is we look for those two numbers that are going to be closest to 0.07. So the number immediately below 0.07 on the table and immediately above 0.07 on the table. We look for those two numbers. And then we have to figure out, okay, which value is going to be closest to the 0.07 that we want. So we just subtract each of them from 0.07 and ignoring the sign. So if we do the absolute value of 0.07 minus 0.0694, we get out a difference or a distance between the two of 0.0006. And if we do the same thing for 0.07 and 0.0708, we get 0.0008. So in this case, the 0.0694 is going to be our closest value. So that's going to be the z-score that we then want to use. So we look and follow 0.0694 over, and we get 1.48 as our z-score. So in actuality, the real z-score for 0.07 is going to be somewhere between negative 1.48 and negative 1.47. You can find that exact value with some technology, so your graphing calculator can do this. But for the purposes of our tests and our class, it's okay just to use the z-score that it's closest to. In this case, it's going to be closest to negative 1.48. Now let's find the z-score that corresponds to the 5th percentile. So in this case, remember the 5th percentile just means the same thing as saying there is 5% of the area at or below that level. So if this is our z value, we know then 5% to the left is what we're trying to find. So the value we're going to look up on our table then is 0.05. And it's area to the left, so we can just look straight from the table. So when we do that, we look up 0.05 on our table. And when we look up 0.05 on our table, surprise, surprise, it's not there. So in this case, we're looking, we have 0.0495, 0.0505. So if we do what we did in the last example, so we take the difference between each of those values and 0.05, you're going to notice that they're equally the same distance apart. So both 0.0495 and 0.0505 are 5/10,000ths of a value away from 0.05. And so that means then that we can actually find the exact z-score. So to find the exact z-score, we know it's exactly in the middle between these two, 0.05 is. So we just go back and we get both of these. So we know it's negative 1.64 and negative 1.65. So then our actual z-score has to be in the middle of that. So we just do the same thing we would do to find the median if we had two values in the middle. So in this case, we just add up 1.64 and 1.65 and divide by 2. So we get a z-score then of 1.645.